Hello children and welcome to the session today. So my dear children, you have already learned what heat is and how heat has an effect on different states of matter. Now today in this session we are going to actually understand how heat flows from one body to another. So welcome to chapter number 5 of your book, Flow of Heat. In this chapter we are going to understand the 3 different mechanisms through which heat is transferred. These are conduction, convection and radiation, and we are also going to understand the effect of these 3 in our daily life. Children, why are there 3 mechanisms for flow of heat? We have understood in the last chapter that there are 3 states of matter: solids, liquids and gases, and these 3 states of matter differ in the arrangement of molecules in between them. That is the reason that method in which heat is transferred in each of these is different. How? Let us understand. So let us first understand conduction of heat through a simple experiment. To prove that metals get heated by conduction, you will need a flat iron foot ruler, 4 brass pins, wax, a brick, a Bunsen burner. Take a flat iron foot ruler. On the foot ruler, fix 3 brass pins with the help of wax. Place the ruler on the table as shown in the figure. Hold the ruler in position with the help of a brick. Heat the far end of the ruler by means of a Bunsen burner. It is noticed that after some time, pin number 1 drops as the wax holding it melts. After some time, pin number 2 falls and so on. From this activity, it is clear that heat travels from the hot end of the ruler to the cold end and without the actual visible movement of the particles. So what did we understand in this simple experiment? That heat was being transferred from one point to another. So what are the important points of conduction? That during the transfer of heat, the molecules do not leave their position. They just pass the heat to the next molecule. Second, very important, the source of heat has to be in touch with the object that has to be heated. Third, the source as well as the object that is to be heated have to be at a different temperature. That means the candle has to be hot and the iron strip has to be cold. If they both are going to be cold, no heat transfer is going to take place. Similarly, if they both are hot, then again no heat transfer will take place. Now children, one more thing that we learned in this experiment was, if you remember the picture correctly, the metal rod was turning red, right? And we had placed a brick on top of it to hold it in place. That brick was already red, so we don't know whether it was turning red because of the temperature. But the fact is, had you touched the brick, it would have been cold. Now the brick here is cold and the iron strip or the iron rod was hot. So what does this tell us? This tells us that iron rod was allowing the heat to pass through it. That means it is a conductor of heat. Similarly, here when heat was passed, was the heat allowed to pass? No, it wasn't, because the brick was cold. That means it does not allow heat to pass through it and it is known as an insulator. So what are conductors of heat? Conductors of heat are substances like iron, nickel, copper, gold, etc., which are heated. When heat is passed through them, they allow heat to pass through them. And insulators like wood, brick, etc. are things that do not allow heat to pass through them. Now, how do good conductors of heat help us? Let us understand from the book itself. Metals are good conductors of heat and they transfer the heat rapidly as well. Therefore, Utensils are made up of metals as being good conductors of heat. They can transfer heat more efficiently to the food to be cooked. Radiators of cars and other vehicles are made up of good conductors of heat as they can easily transfer heat from the engines. Freezer of refrigerators are made up of metals as they can easily take up heat from the materials to be stored and preserved at low temperature. Now children, this was the utility of conductors. Let us now understand the utility of insulators or poor conductors of heat. Mostly non-metals are poor conductors of heat. Some of the applications of poor conductors are handles of electric iron and wok are made up of wood or bakelite as these do not conduct heat. Frozen food is often stored with ice in thermocol boxes as they are poor conductors of heat and do not allow thawing of food items easily. Similarly, vaccines are also stored in insulated boxes made up of foam or thermocol which prevents their efficacy by preventing them from extremes of heat. Refrigerators are double-walled and the cavity between the walls is filled with insulating material like PU foam or glass wool which prevents heat from reaching cold items stored inside the refrigerators. Children, also geysers in our bathrooms keep the water hot for a very long time. This is because these geysers also have a layer of glass wool that prevents the heat from escaping outside. If you've ever traveled in air-conditioned coaches in the train, you would notice that the glass windows of the AC coaches are actually double layered with air in between. This does not allow heat from outside to enter the coach inside. The next thing that we are going to learn today is convection of heat. So children, conduction of heat takes place from molecule to molecule. So when it takes place from molecule to molecule, what is happening here? The molecules have to be in close contact with each other. So where does conduction takes place? It takes place in solids. Now let's come to convection. Convection is the process of heat in which the matter or the molecules move. Coming back to conduction again, here heat is transferred from one molecule to another. The molecules are not moving from their place. There is one more reason why molecules are not moving, because in solids they are very closely packed. So even if they want to move, where are they going to go? No place to go, right? In case of liquids and gases, so these are liquids and these are molecules in gases. We can see the difference in the space. So here if the molecule wants to move, it has got space to move. That is why which method of transfer of heat? It is convection. What is the mechanism of convection? Now in convection, what is happening? The molecules of liquid or gas, they are present as a layer, one on top of the other. So what is happening? As given in this experiment, you will see if you conduct it in the school laboratory that the liquid at the base of the beaker will begin to heat first. So here they have placed a piece of pink color potassium permanganate. Now when the potassium permanganate at the base of the liquid begins to heat, it begins to rise because the heated molecules at the base of the beaker begin to rise up and the colder ones take their place. So what is formed? A convection current is formed until the whole beaker, the whole amount of water in the beaker will begin to heat up and boil. So these are the mechanism of convection currents. Now let us quickly understand the application of convection in our daily life. So it is given in a list in your book as we can see on the screen here. So application of convection. In workshops and factories, chimneys and circulating ventilators are provided at the top. This is to allow hot, lighter air from the machinery and furnaces to escape and keep the lower regions cool with the help of convection currents of air. In centralized air conditioning of the large buildings, the cool air circulated being heavier settles to the lower habitable part where hot air being lighter moves up through the convection current and is allowed to escape out through the central ventilation ducts. This keeps the building cool. Convection is also observed in nature in the form of sea breeze and land breeze. Children, let us now understand the concept of sea breeze and land breeze through a video. Convection currents in nature can be seen in the form of a land breeze and sea breeze in the coastal areas. Sea breeze blows during the daytime from the sea towards the land. The land gets heated faster than sea water. Hence, the air above the land also gets heated, expands and rises up. The cooler air from above the sea surface blows towards the land to take its place. Land breeze blows during the night from land towards the sea. Land loses heat faster than the sea. Hence, during the night, the sea water is warmer than the land. The air above the sea is also warm and rises up. The cooler air above the land blows towards the sea. This sets up a convection current. Having understood conduction and convection, so conduction takes place in solids, convection takes place in liquids and gases. But is there anything that can take place without the medium, that can take place in vacuum? Yes. Radiation takes place in vacuum. Children, we all know a very simple thing, that Earth survives because of the heat of the sun. We know that the area around the Earth is covered by air, which is known as atmosphere. But what about the universe? The distance that the sun is traveling, the heat from the sun is traveling to reach the earth, that distance is without any medium. There is no air there. So what is there? There is absolute vacuum. So can transfer of heat take place in absence of any medium? Yes, it can. Another beautiful example that has been given in your book is the example of an electric bulb. If you read the text carefully and look at this picture thereafter, you will realize that inside an electric bulb, the filament and the glass case, there is absolute vacuum. There is no air. Even then, the case, the glass case gets heated. The heat is radiated outside. So what is happening inside the glass case? Radiation is taking place. So therefore, children, radiation is a means of transfer of heat in which no medium is required. Now, what are the applications of radiation? Let us take a closer look and understand the same. So, in radiation, the application of radiations, the base of the cookware is painted in black. This helps to absorb more heat and cook food in a lesser time. The corrugated roofs are often shiny in appearance or are painted with light color. This helps to reflect back more heat and keep the area under the roof cool. In winter, dark colored clothing is preferred because dark colored clothes absorb more heat and keep you warm. Then the tires of vehicles are preferably black in color, as dark color is a good absorber as well as a good radiator of heat. This helps the tires to cool down quickly in summers. Now let's go to the other two main points. Polished shoes heat less in comparison to unpolished ones. It happens because the shiny polished surface reflects most of the heat, whereas dull surface absorbs the heat. The conducting pipes of solar water heater are painted in black and insulated inside a glass case. The black surface absorbs heat in comparison to the shiny surface. So children, a few major principles like dark colors absorb heat, light colors reflect heat. Dull surfaces will absorb heat, shiny surfaces will reflect heat. If we understand all these principles in our daily life, we will be able to create a situation where heat does not trouble us much, right? So in this chapter, we have studied the flow of heat through 3 different mechanisms, which is convection, conduction and radiation. So I hope you have really enjoyed and understood the lesson. Thank you so much.